All right, everybody, welcome back. Day 3. Today on the docket is mensuration. So finding out the area and volume of shapes, etc., etc. So this is the kind of question we'll be going over today, which is if I give you this shape and I tell you the area of one side is 10 centimeters, can you find the area of the shaded region? So I'll let you think about that for a second. All right, this one's quite tricky actually. On the website, idealfundamentals.com, go to notes, and then under notes, today we will be working on mensuration, all right? So this section, so you guys can all open that up together, and we'll go through it. So starting off with why we should care for mensuration. So interestingly, what I think mensuration is not really about just finding the surface area, perimeter, or volumes of the shape. I actually think this topic is primarily about decomposition and decomposing complex shapes into smaller and smaller components. And it's this skill of decomposition which is extremely, extremely valuable, especially in engineering and computer science. So let me show you this video of this. This is a room drawing. So you can see how nicely the room is drawn. And I'll show you how this person drew this room by breaking it down into smaller and smaller pieces. So
I swear I have been doing things, it's just not been YouTube.
So you can see how this person first drew a couch and then, here, let's start from the beginning. So they drew a room, they drew boxes on it, which then became a bed, right? Then they added more boxes for bookshelves and a mirror, more and more boxes. Then they added lamps and stuff, another box for a shelf. They put shapes in the carpet, another box was turned into a, I don't know, I guess a safe or whatnot. But they just kept adding more and more things, smaller and by smaller and smaller additions. And that at the end led up to this, right? So this person broke down in their head this complex painting into tiny portions that they did one by one. So quick poll. Isn't this pretty cool? Isn't this skill a pretty interesting skill? Yes or no? Yeah, it's really cool. Yeah, I agree with you. And actually, this is one of the biggest things in mathematics. Is this not really? Maybe you won't need to compute the surface area or whatnot of a shape in your life, but you will need to break down complex things into smaller shapes. So let me show you how I used this aspect of decomposition in my undergrad. So for one of our homeworks, we had to draw a real world object. And so I will show you my beautiful, beautiful drawing. So what I drew is a soap dispenser. This is a soap dispenser here. And what you can see is this big soap dispenser has been broken down into smaller pieces. So this is a circle that I drew. This arc here is part of another circle here. These are lines, another circle here, another circle here, line, 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 circles. So this entire drawing was just constituted of just circles and lines, as you can see here, right? And if you take this piece here, then this also was broken down into smaller circles. We have line, then a circle here, then a line, line here, lines, 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 circle here, right? So using just circles and lines, I was able to draw this entire shape. This portion here is the handle. So there's no handle here, but you can see this handle also is made up of a bunch of circles, right? Of radius 10, it says, it gives you the radius here. And so by using this concept of drawing a circle, then maybe removing a part of the circle, then drawing another circle, removing a part of it, you can build really, really complicated things. And all of these can be annotated. You'll see everywhere there's an R, it's a circle. And everywhere it's just this, it's just a straight line. So many circles were used are, I can't find the R's here, you can see diameters are shown here. So this entire shape was just built of circles and lines. So let me show you this really quick. which is, I love this thing that we learned, which is you can draw a circle on your own using just lines. So these are construction lines. Then you cross here, like this, right? And then you cut each segment into 1/4. So 1/4 up here, 1/4, 1/4, 1/4. And then you can draw this portion here, this portion here, this portion here, this portion here. And then if you remove all the construction lines, oops, then you will have a pretty beautiful circle, right? This is pretty beautiful. Let's see how it matches onto a perfect circle. Look at that, it's pretty cool, right? I drew almost a perfect circle by doing that. So that's how you can draw circles. And interestingly, you can also draw them on a diagonal plane. So if you take a look at this, I can draw a circle in perspective. So same thing was done. And then what you can do is you can take these, copy and paste it, and then you can like add them together. All right, so let's add this together. And then you can draw a very nice cylinder. You just connect this point together here, and maybe this point together here. Let's see. Okay, and then let's remove all the construction lines. Not this one. There you go. This is a pretty nice cylinder, right? Oh, we have to remove the inside. There we go. So I just drew a cylinder. So what do you think of my drawing skills? Aren't my drawing skills awesome? Yes or no? Yeah, my drawing skills are very awesome. Thank you. Good. Cool. All right. So this is basically where decomposition can be used, and this is where the mensuration portion comes in pretty well. So for today, the pure notes that you will need to know is everything in here. I would really not be pro. I don't think it's that important to memorize. It's more important to understand how these are built up. So we'll get to that actually today. So we'll get to that later on. But just know that it's not important to memorize. It's more important to understand how these are built up from its smaller portions. And we'll go into area conversions later on. But let me show you. So let me jump into the first part, which is really this decomposition portion. So we're going to use this very simple shape here to talk about decomposition. Okay. So if I want to figure out the area, and this is pretty simple, you should be able to do this in your head, but it's not the answer, it's more the process that we're going to focus on. So what you'll notice is this is basically a shape that's like this. So the green is all of this, right? Minus this shape here, right? Minus this purple shape. So if you want to figure out this area, then this is 8 centimeters by what? 3 plus, there's a line here, so 3 and 3, so by 9. 9 centimeters. And here we know this is 5 centimeters and this is 3 centimeters, right? So the area is then this area minus this area. So it's 9 times 8 minus 5 times 3, okay? So it's not about the answer, it's about the process. The main key process that I want you guys to take away, and that we'll practice a lot today, is this concept of breaking down this big shape over here. Well, I guess that's not working. This big shape here into its smaller components, into its 2 rectangles, all right? So take a look at this one. Again, this one should be pretty simple, pretty straightforward, but just put into chat, put down what are the 2 shapes that you can break it up into. So break down this big shape into its smaller shapes. Good, yeah. Good, so some people are saying square and circle. So let's go with that. That's actually interesting. So we have a circle here, and then we have a square here, right? So what you can do is you can say, okay, half a circle plus a full square, right? And again, so what's the radius of the circle? Radius of the circle here is 10 divided by 2, right? Because this is 10, and so divided by 2 is 5. And then what's the length of one side? The length here is equal to 10, right? And now you have all you need to do this. You could also have said semicircle and square. That's also correct. Some people wrote down triangle, so that also works if you want. So let's remove this. What you could do is, let's take blue. You have this triangle plus what color should I take? Purple. Plus this triangle here, right? Again, this is not wrong. It might just take you longer to get to the answer, right? So this also holds true. But if you do this, then you need to find what's the base and the height, right? Or what you may notice here is that actually the blue and the purple triangle are the same. So what you can do is remove the blue triangle and just multiply this purple triangle by 2. So you can do 2 times this purple triangle, right? So are you guys with me so far? I just did quite a lot. Yeah, okay, so far pretty straightforward, right? So the way you break down the shape, and if you're not with me, can you private chat me so I can address that? If you have any questions, just private chat me, public chat me, whatever, I'm perfectly fine. But the key is you can break down a big shape into many, many different shapes, into triangles, circles, squares, trapezoids. They all look the same, but you get the point. The practice that we need to do is we need to practice the decomposition, but actually this smart decomposition. Because calculating areas of triangles, circles, and squares should already be pretty easy for you. It's a smart decomposition that they test you on the exam, all right? So let's do this shape now. Using addition and subtraction of different shapes, I want you to figure out how you can get this shape. So there's a couple ways to do this. Take a minute or so to think about it. If you find one way, then pause and try and think of another way, all right? Again, if you find one way, pause and try and think of a different way to do the same thing. There's 2 different ways. One way is you have a square here plus this rectangle here. Actually, I'm not sure if this is a square. I'm not sure if this is a square. Let's find out. And then you have 2 triangles here, right? So the answer is a square plus, or a rectangle, 1 square / rectangle. Oh, actually, it's not a square. No, it's a rectangle. It just gives it to you 2 meters and 1.6. So a green rectangle plus a purple rectangle minus 2 times this triangle, right? Now, this is one way to do this. Another way to do this would be, let's remove this, would be, let's take another shape. This rectangle here plus, let's try brown. No, brown is too light. Pink, plus this trapezium here. Okay, so you have, let's do this down here. Green rectangle plus blue rectangle plus pink trapezium, right? So let's do both of these now. Let's do the next step for both of these, which is how do you find the area of this? So the area of a square, we know you need, rectangle, sorry, you need the base or the length and the width, right? So let's do length and width. So here length we know is 1.6 and width is 2 meters. In the previous drawing we had, which was all of this, this length was 1 plus 1 plus 1.6, right? This plus this plus this, that's length. And then the width was 0.9 plus 0.9, right? Because there's a black line here, black line here. So both of these are the same. And then in the triangle, what we need base and height, right? So if we come over here, this is the base, this is the height. So the base is this length divided by 3. So base is then equal to 1 plus 1 plus 1.6 divided by 3, and the height is equal to 0.9, okay? Now you have all of the things that you need to solve for the area of this shape. You just plug into the equations. Now, obviously, I'm going through this pretty simplistically. A lot of this can be simplified and done in your head, but again, I want you to focus on the process, not on the answer, right? We're focusing on the process that we're going through. Same thing can be done over here. We already have this. This one would be 1 plus 1 plus 1.6 times 0.9. The height is 0.9, right? Here. And then for the trapezium, what do we need for the trapezium? Let's go up to the areas here. We need base 1, base 2, and height. So this, and this, okay? So if you broke this down into this shape, you will notice this is a little more complicated. Because so you have B1, which is equal to 1 plus 1 plus 1.6, H, which equals 0.9, and B2, which is equal to 1 plus 1 plus 1.6 divided by 3, right? So it's up to you. I mean, maybe this is easier, maybe this is easier, maybe this is easier, whatever. But the point is think a little bit about the shapes that you break it into and how that works, okay? So let's do this one now. I want you guys, again, to put in the chat, what is the breakdown of this? How do you break this down? So we're going from a 2D shape to a 3D shape. Okay, good. People are saying prism plus cuboid, yeah. Someone said circle. I'm not sure how circle. Maybe you can expand on that more. But basically, this is your cuboid here, right? And then this is your prism. Okay. So what do we need for a cuboid and a prism? So we need. Look at that. Look at my drawing. So good. What are the things that we need for cuboid? We need base, height, and width. And for prism, do we have prism up here? Let's take a look. We don't have prism. Okay, so it's just triangle times length. Sorry, it's base, height, length. Base, height, length. Same thing here. Base, height, length, right? So length we know is 6 for both of them. For the cuboid, we know that the base is 3.5, the height is 2. Now here we get tricky. Now we don't know the base and the height here, right? Actually, sorry, we do know the base, 3.5, right? It's this length here, which is 3.5. The height we don't know. So we use the same thing which we did on day 1, which is let's see how we break this down further. So for the height, what we can do is break down this triangle. Let's use white. We'll break down this prism into this right angle triangle. Okay? So we bring this down here. We have a right angle triangle. We know this is 3.5 divided by 2, and we know this is 2.5. So using Pythagoras, you can now get the height, correct? So this can go into here. So again, this is slightly a complicated problem because it has this extra step here, which we just did. But it's really simple if you learn this decomposition aspect and break it down into smaller pieces. You know how to use Pythagoras' theorem. You know how to calculate the area of a triangle. You know how to multiply it by the length. And you know how to calculate the area of a cuboid, right? So when you're practicing this, I would not really practice this math. Like, notice how I'm not doing the algebra or the math, right? I'm not really doing it right now. What I'm practicing is this concept of breaking it down into its smaller components. Because I'm pretty confident you guys can do the math, and I encourage you to do it later on as well. But right now we're just practicing this concept of breaking it down, all right? So let's keep going. Let's pick it up a little bit. This one's a bit more difficult. Let's see what you guys can come up with this one. Again, we're just working with area for now. So what's the area? So I'll give you a minute. Let me give you a hint. If you're struggling with these, with the pies, notice all of these pies and see what happens with all of these pies. Okay, all right, let's go through it with that hint. All right, so what we have is we have a bunch of squares. So it seems like we have squares, pies, and hexagon, right? These are the three basic components. So what you'll see is the square is pretty simple. So we take a square. How many squares are there? 1, 2, 3, 4, 5, 6. 6 squares plus 1, 2, 3, 4, 5, 6. 6 pies plus 1 hexagon. Oof. All right, let's see. Nice. Hexagon drawing skills on point. All right, so we know this area is pretty easy, g squared. This area of the pie you may struggle with. So what do we need here? We need, to get the area of a pie, we need theta over 360 times pi r squared, right? So essentially we need theta and we need r. So r, we know this length here, we know this is g. R is equal to g, correct? Theta is tricky. So whenever you are stuck with this thing, look and see how else you can put this together. So what you will notice is, let's say if we remove this here, then this side and this side will stick together, right? If we remove these things here, then this side and this side will stick together. So this will end up making a nice semicircle. So if you take all of the pies, you will essentially have a circle divided into 6 pieces. And you'll sort of have to visualize this fact that, like, if you take these pies and bring it into the center, if you join all of these points here and you bring it to the center, then you will see how these slot right in and make one full circle. Arithmetically, it's tough to prove, but essentially visually you can derive that. So let me remove all this. So then what does this theta become then? Well, then theta, you don't really need it. You don't need this because you just have a circle. So the area is pi r squared. So you don't even need this, right? Or if you must, then you know that theta is equal to 360 divided by 6, right? So then you have 6 times 360 divided by 6 divided by 360 times pi r squared. Is that correct? Yeah. So 360 cancels, 6 and 6 cancels. So you're just left with pi r squared, okay? Now, same thing for this hexagon here. Either you know how to find the area of hexagon, which we don't have here, or how can we break down the hexagon further? So let's come back into here. Let's break down this hexagon further. We can break this down into a rectangle in the center and 2 triangles, one up here, one up here. Or you can break this down into a rectangle in the center and 4 triangles, right? So 4 triangles is easier because 4 triangles equals to 2 rectangles, right? If this is base and this is height, then 4 of these triangles becomes 2 base times height. So you don't even have to do half, right? So you can keep decomposing this further. So quick question, are you with me so far, yes or no? Good, okay. Some people are asking if we're gonna do a Kahoot today. Today we actually have a different activity lined up, which you may enjoy. So we'll see, I guess we'll find out in the feedback if you enjoyed it. Let's do this one. We're gonna get a little bit more complex now. Let's do this one. I'll give you guys 30 seconds to do this. Okay, yeah, this one should be pretty straightforward. Oh my gosh, I can't even draw this. Well, it's two of these things plus one of these things, right? It's basically two of these cylinders, different color. Two of these cylinders plus one of the center cylinder, right? That's pretty straightforward. So for cylinder, what do you need? You need radius and you need height. So we have the radius for this cylinder here. Wrong color again. We have the radius for this cylinder here, and the height is 4. Same thing, we have the radius for this cylinder, and the height is 12. Yeah, pretty straightforward. All right, let's try this one. What about this one? Okay, so this one is just pretty straightforward, or maybe not. Hemisphere, 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 or semicircle, semicircle, semicircle. So it's basically 1, 2, 3, 4, 5. 5 times these semicircles. So that becomes 5 times 1/2 of 5 squared, right? And here we have r. We don't know the value of r, so this is your formula, right? Good. Or again, if you struggle with hemispheres, you can do 5 times 1/2 circles, right? This is pretty straightforward. All right, this one's interesting. Now I want you to find the area of white region, okay? And what you need to know is that this is D. What is the area of the white region in terms of D? So think about this. Like, it's pretty cool. You are able to find the area of the white region with just one, all I give you is one measurement, and you'll be able to find the area of the region, right? Yeah, so many of you are noticing that there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 6 and 6, 12, 24 circles. So there's 24 circles. And you are noticing that to do this, you need to do the big, this color, the big blue box minus the 24 circles, right? Now the question you may struggle with is what is the dimension? What's the width and height of this box? So to do this, what you need to notice is that you have all of these D's are basically next to each other, right? So all these diameters are next to each other, and then similarly, diameter, 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 diameter. So you have 4 here, 4 diameters here, and 1, 2, 3, 4, 5, 6 diameters here, right? So now you can get this. So the area of this rectangle minus the circle. All right, so this was in the formula booklet. Now if you have this formula memorized, think of this one, and I want you to do 2 things. One is, what is the volume? Is 1, and 2, what is the surface area? Okay, I want you to find the volume and the surface area. Not using the formula, see if you can derive this on your own by breaking it down into smaller pieces. And if you need a hint, this is the bottom part of a cone. Okay, if you need a hint. Yeah, bottom part of the cone. Okay, let's go through this. So what this becomes actually is, let's move this one down slightly. If you extend this thing, oops. If you extend this all the way up, and you will see this is a bigger cone, right? So let's say this green is big cone, and then inside of the green we have a purple smaller cone, right? So this is green cone minus purple cone. All right. So so that becomes a volume, and you know how to get all the radii. The radius here is 4, and up here, radius down here is 8, right? The height you've been given. Interestingly, we don't have the height of this piece here. So how can we find the height over here? Yeah, okay, so people are saying ratio. This one's a little tricky. So you essentially have, let's break this down even further. You have this triangle here, and you have another triangle here. And so you know that this is 8, this is 6, and this is 4. And so therefore, if this is 4, this is 8, and this is 6, this has to be 3. And so that becomes 9, right? Let me know if I did my math correctly using congruent triangles. So yeah, so that's how you can break this down further. Cool. And so for this was the answer to 1. Let's do surface area now. Ignore this for a second. Bring this back later. Surface area is the surface area of the big cone. So actually same thing. So same thing here. Surface area of big cone minus surface area of small cone plus the base circle, which is this thing right here, right? Plus top circle. So plus this top circle, right? And again, we know the radius is there. Cool. Ajay, how are we feeling? Do we want a little break? How are you feeling right now? Do you want a break? Yes or no? Okay, let's do this break. I would like everybody. So let's say you got your final exam back, and in one question you made a mistake. All right, in your final exam, let's say you got it back and you made a mistake. Can you put into chat, why do you think you may have made that mistake? Like, what may be the cause of that mistake? So can you put that into chat? And try to get to the cause. So I like this first answer because I got it wrong, okay? But what was the cause behind? Like, why did you get it wrong? What was the cause of that mistake? Okay, great, we're getting really good answers here. So somebody said a calculation error, okay. So tell me a bit more about calculation error. What exactly went wrong in calculation? Somebody said anxiety, okay. Somebody said they did not read the question properly. A lot of people, wow, a lot of people said carelessness. Okay, so silly error. See if you can break down this concept of silly error into its smaller pieces. Can you decompose this further? What type of silly error? So we have never memorized formula. All right, I'm gonna start writing these down. These are really good. So never memorized formula. What else do we have? Can you break down carelessness? Can you break down calculation error? Yeah, type value into calculator wrongly. Yeah, that's a really big one, right? And that's interesting. It is interesting that none of you have put concept gap in there so far, right? Like, just notice how none of you have put concept gap, that you don't know the material. So, so I want to ask you a question now. Are you doing your practice such that you are addressing these potential problem areas? So in your practice, are you addressing these potential problem areas? These potential problem areas of using a calculator, misreading the question. What else is there? Anxiety or syntax. I would also like to add handwriting in there. I made a lot of mistakes with handwriting. You've seen my handwriting. And this is me trying. My 4s would look like H's and I would mess up. Yeah, so the main point is just what practice you're doing. Some of you are, some of you are not. The practice that you're doing is make sure you are focusing on these. When you read the question, practice reading the question properly. When you are using your calculator, just make sure you are conscious about how you're plugging in numbers into your calculator. If you make a mistake on that, practice that. Literally just get formulas or a whole homework and just plug in everything to your calculator and make sure you're not making a mistake in that process, right? If you're anxious, then see what you can do to get rid of that anxiety. We'll talk about that in a later session. If your handwriting is bad like mine, see if you can slow down. See if you can learn how to write your 4s and H's differently. So I actually had to do that. I started writing my 4s completely differently. so I would not make a mistake. Yeah, good. Good. So we'll do one more question and then we'll have the activity that we have for today. But yeah, so these are all the errors that you guys mentioned. So just we're gonna keep these here for now. See how you can do the practice such that you're addressing these. Okay. All right. This one you may remember this question from a long from one of your past papers. But see if you can break this down into its smaller pieces. All right, yeah, this one took me a while. Actually, I'll give you another 30 seconds if you've not done this one. See if you're able to break this down into its smaller pieces. So there's definitely a semicircle here. Good. And then what you can add in is you can do this triangle and this triangle, which is the same, right? Plus this sector of a pie and this sector of a pie, right? Now you know how to do each individually, right? You know how to calculate the area of the sector and area of a triangle, and you know how to calculate the area of a semicircle. The tricky piece over here may be actually how to get the theta value of the two sectors. How do you get that theta value? Anybody have any ideas? How do you get theta? Well, maybe what we can do is let's say this is green theta. So orange theta is equal to 180 minus green theta, right? And green theta is equal to 1/2 or 2 times purple theta, right? So this is purple theta, 2 times purple theta. And for purple theta, we have, let's do purple theta. We have a triangle. We know the radius is 17. And we need to find the height. The height is 25 minus 17. Right, so if we have the length of 2 sides, then we can find theta using the sine cosine rules. So again, we just broken this down into smaller and smaller pieces, and then you can go back up like the recursive method. All right. So let's go ahead to the last 2 pieces that I have on converting units and radians. So this one comes up pretty often also, it seems like, in your exams. So let me show you what that looks like. Okay, so converting units actually looks complicated, but is really, really simple once we try this method, all right? So this method will help a tremendous amount for units. So we know that this shape is equal to this shape plus this shape, right? So there's 2 ways to do this for units. One is you convert at start. Okay, so if you convert at start, then what we have is we have 1.5 meters times, and notice I'm leaving space, times 3 meters plus 2.5 meters times 1.5 meters, okay? Now, when you're converting from meters, let's say we want this in centimeters squared. Okay, we want the area in centimeters squared. Okay, let's say this is the question. So you can convert the units at the start, and the way I do this is I always remember to write down your units beside your number. So always write down the units here. And this is why, because when you convert this, you can see that you multiply this by 100 centimeters divided by 1 meter, right? So you know that 1 meter has 100 centimeters inside, right? It has 100 centimeters within it. You know that. So by multiplying this, what you can do is then cross out the meter, and then you are left with 1.5 times 100 centimeters, right? So this becomes 1500 centimeters, right? So you do the same thing here, same thing here, same thing here, and you get the answers, right? The other way to do this is convert at end. You can convert at the end. So if we take this line here, for example, this becomes 1.5 centimeters times 1.5 meters times 3 meters is equal to 4.5 meters squared, right? 4.5 meters squared. Now to multiply this, again, we have the units in meters squared. So meters squared is equal to meters times meters, right? So what you'll do here is you'll multiply this by 100 centimeters times 100 centimeters divided by 1 meter divided by 1 meter. So then this and this will cross out with these two. So you're left with this becomes 4.5 times 100 times 100 centimeters squared. All right, does that make sense? I'm a quick question here. I did this pretty quickly. Did that make sense? Okay, all right. It seems like it made sense. We'll do 2 more of these, slightly more complex, and then that will make a lot more sense as well. Okay. All right, so let's do this one here. You have I really upped up the difficulty in this one. All right, so you have this square here with feet on the side, and you want the area in centimeters squared. So think about this. How can you do this to get the area in centimeters squared? Try to keep that approach of multiplying the units and the ratios so that the units cancels out. And I'll show you why that's really important. So let's do approach 1. So let's convert 5 feet to inches, okay? Sorry, 2 centimeters to centimeters. So then this becomes 5 feet times, we have 1 foot is 12 inches. So this is where some people get tripped up. Is it 1 divided by 12 or 12 divided by 1? Can you put in the chat? What is it? Is it 1 divided by 12 or 12 divided by 1? Yeah, okay, good. You guys are getting it. So just to make sure, let's say you don't get it. So let's say you do 1 divided by 12. If you write down the units, sorry, it's actually, let's do yellow for inches, and let's do green for feet. Then what you'll notice is that feet and feet don't cancel, right? This becomes feet squared. So that's how you know. That's how you know that this is not 1 divided by 12. This is actually 12 divided by 1. So 12 inches in 1 foot, right? Then you do multiplied by, okay. We need inches to centimeters. So we have 1 inch, or no, let's do 0.254 meters. Oh, actually, this is supposed to be 0. Yeah. And notice I'm purposefully making a mistake here, which is 0.0254 meters per, oh, I guess I'm not, per 1 inch. This inch and inch cancels out, right? And then this feet and feet cancels out. So you have 5 times 12 times 0.254, that's the meters, okay? But we want them in centimeters. So we keep going. Let's do this color now. Multiplied by, we want meters by centimeters, right? So we have 100 centimeters per meter. So again, meter cancels. All right, so does that make it easier? Does that help? Yes or no? Does this make it easier? Okay, interesting, 50-50. All right, maybe this is already easy for you, but if not, then this should help. This is actually a lot more helpful for the radians section. So let's come down here in radians. So the rule for radians is pi radians is equal to 180 degrees normal degrees, okay? So if I give you 360 degrees, then you will do 360 degrees times something divided by degrees, right? Times pi radians divided by 180 degrees, right? So the degrees cancels out. And then essentially 360 degrees ends up becoming, this and this cancels out, so 2 pi radians, right? Cool, all right, so this was the total for the easy part. We'll just do 2 quick questions, but I want you all to just, if you have these pure notes, I want you to add this area conversion piece into your pure notes that you can convert. Actually, it's not area conversion, it's unit conversion. You can convert units, e dot meters, into centimeters by multiplying by ratio of units and their units. So you got 1 centimeter equals to 1. Let's do this times multiplied by, let's say you want to convert meters to inches, so you then would do meters at the bottom, inches at the top. And then I forget what the number is, but you would just convert it like that. So your centimeter cancels, meter cancels. And that's how you do the conversion, okay? All right, so we'll do the last 2 really tough problems. So let's do this one. This is slightly too difficult for what you guys may get, but I just want you to think of this problem, to practice this decomposition portion. Can you decompose this problem into its smaller components? So I'll give you guys a minute to do that. Okay, and if you want a hint, here's a hint. What if I told you to first find this area? What if this was the question? Then can you get the answer? Okay, so let's break this down. So if you notice, this is one big rectangle, right? Minus 2 circles. So these are the 2 circles, right? All of this divided by 2. Do you notice that? So if the question was just the current red shaded portion, right? Like everything here. If this was the question, then it's just one rectangle minus 2 circles. But because we're not including this, it's 1 rectangle minus green circle divided by 2. Wasn't that a cool problem? Quick poll. Yes or no? Wasn't that a cool problem? Oh, very interesting. Oh, somebody has a really interesting one. Okay. Someone is saying that this is also equal to this triangle minus the circle. And I think we can get to that. Let's prove that out actually. Can we prove that out? Let's see. So if we divide both sides by 2, then this becomes divided by 2. So this is what we're left with, triangle. And then we're minusing this. This is also crossed out. Yeah, so it's triangle minus circle. Nice, awesome, good. I didn't catch that. Good, fine. All right, let's do this one. This one is quite tricky. Let's just do find the area of the rectangle in terms of R. Can you find the area of the rectangle in terms of R? So you'll notice quickly that this is R, this is R, this is 4R, right? The tricky part is this piece, is the width. So this is R, and this is R. Or let's do these 2. This R and this R, there's an overlap, right? So the width is not actually 6R. It's not 6R. How can you fix that? How can you solve for that? All right, okay, let's try this. So let's say I start with this radius. This is one radius. Here's another radius. Okay, I don't get there. Let's do this radius plus this radius plus this radius plus this radius and plus this radius. All right, and let me change the color here also. So now I've gone from one side to the other side of the length. So what I can do then is take this shape here, right, and break this down. And this is 2r, and I know this is 2r, so I can get this length here, right, using triangle theorem. Right, does that make sense? You would need one more thing. You would need the angle here, right? So this would be 1 over 3 times 360. So this would be 60. No, 120. You need this angle. This one's tricky to get 120. You basically need to see that if this shape is touching here and here, then this is the same, this is the same. And then this is 1 unit, this is 1 unit. So you have 3 of these units. And so that's how you get this. All right, so there you go. Now you have whatever this thing here is, you can calculate that, but now you have the length as well, right? Plus 2r, this r and this r, right? Easy, cool. Oh, let's do one last one. All right, fine, we'll do one last one. This one's really tough. How can we do this one? And look, if you're not getting these, that's perfectly fine. Like these are way beyond what's going to be done in the O levels. But the skill that we're practicing is just looking at a shape and breaking it down into smaller and smaller shapes. Ignore the width, the green width, and the purple width. Ignore that. Okay. So there's two ways to do this. Let's go through both ways. Let's go through the first way. So let's say I break down this into these 4 shapes. Right, these 4 shapes are the same, right? Same 4 shapes. Then if I take this shape here, and I'll do something interesting. Notice I'll do something interesting. Which should have used a different color here. Now that should hopefully give you a hint, which is how to get to this overlapping area here. How can you get this overlapping area? Well, let's say we break this apart. Right? If we break this apart, then this is bigger than the square, right? This is bigger than that purple square. Let's do, oops. Still. Okay, so what you can do then is you can minus out. You can do purple square, which is this square here, minus, and then the sum of these two, this plus this. Oops. Actually, here you'd get a negative value, so we'd have to bring the square on this side. Minus. Right, does that make sense? Because when you overlap this, the shaded region is the overlap, right? So then if I minus the square, if I take this and I minus the square area, then I'm only going to be left with the middle region. Does that make sense? Yeah, then once you have this down, then you can just multiply this by 4. And notice I'm not doing any of the math. Like the math is pretty straightforward. It's this decomposition piece that's important, right? Super. Okay, I think that was all we had for today. So hopefully this was a helpful session for you. All right, so we'll go over this last question. Let's say this was filled with green. All right, and this is filled with yellow. Okay, so let's say I add these two. All right, so what I have then is actually, if we cut this into, okay, so what I have now is this green box plus this yellow box, right? This makes a square, all right? Plus these two things here, which if you rearrange them, they become your center leaf, right? Does that make sense? So this is why from this, we minus this triangle, this square. Because once you minus this square, all of this goes away and you're only left with the thing that you want. Did that make more sense? Or should I explain it in a different way? Yeah, Surya, you have another way? You wanna explain it?
So I was thinking, well, instead of because at first I didn't understand the adding of the two sectors. So my plan was, instead of doing this, we could take the square and just minus off the quarter circle from it. Then you get the empty area that's the empty area, if you can see from the figure that they've given. See the empty area above?
That is genius. I love it. Okay, good.
Then you can just times the number of empty areas there are, which is 8, and you can instantly get the answer.
Nice, good find. All right, so you were saying you take the square and then you minus, let's do it in green, you minus this. So if you do that, then essentially you're left with this empty area, right? This white area. And then you just multiply this by 2. Nice, that's genius. That's 2. Because there are 2 empty areas there, right? This area, this area. So now you've gotten now you've gotten the white area, but we're looking for the shaded region. Okay,
then
so
we can minus it off the total square area, which is 10 times 10, or 100.
so then we can minus it out from this. Good. Actually, let's do some algebra on this. So we have square minus 2 square minus 2 semicircle, or 2 regions. So this becomes minus square. This is plus. And this becomes 2. So we get the same thing we got before by doing algebra on these shapes. Pretty cool, right? Yeah, good. Awesome. Super. All right, that's all. See you guys tomorrow then.